Okay, students, let's look at count-controlled iteration. So Edexcel GCSE specification says that iteration is related to count-controlled loops, which are essentially for loops. And there are two different types of loops we can have in programming, for loops and while loops. And while the term iteration technically also applies to while loop, just for the sake of simplicity, it will be related to for loops for Edexcel. Okay, so they'll use this terminology in exam papers, count controlled, and you've got to remember that's a for loop. So what is a for loop? A for loop is a way of iterating, looping, or doing something for a range of things and then stopping. So an analogy I could give you is counting cards. You've got a deck of cards and you give them all out, and at the end you're done. Like, you've got no more cards to give out. It will always stop. A for loop is always going to stop. So a typical for loop might be for count in range, and then you have a range of numbers. Now you can either put just a value in here like 10. I could say print count, and count is just a temporary variable name that I can call anything I like. I could say for I in range, I could say for number in range. It doesn't really matter. It's just a temporary variable that will take on the value of a number. So in this case, it will give me from 0. Let's run again. It gives 0 to 9. So why is it giving me 0 to 9 when I put 10 in there? So what's happening in this bracket is a stop value. And stop values is up to but not including the stop value itself. All right. So if I wanted to go from 1 to 10, I would need to slightly modify this. In Python programming and most other programming languages, they count from 0. You count from 0. So if I wanted to print the numbers, instead of 0 to 9, I wanted 1 to 10, I can have a range in here. So I can put the start value, the stop value, but I need to make the stop value 1 greater than what I actually need, because it will go up to, but not including the stop value itself. So if I put this in, it will give me 1 to 10. It will stop before it gets to that 11. So it's a bit, and it's not as intuitive to get your head around, but once you understand that we count from 0 in Python, and the stop value is up to, but not including the value itself, things will be a bit easier for you. So we can have a range function that takes 2 parameters, and we can also do something clever and have a third parameter that is called step. So I'll put in here another note. Start, stop, step are the 3 parameters we can have in the range function. So if I put 2 in here, what that's essentially allowing me to do is count in 2s. So I've got 1, 3, 5, 7, 9. So if I wanted to just have the even numbers, I could have my start value as 2. And this will give me 2, 4, 6, 8, 10, and it will stop at 11 before it gets to 11. So you can use the step function to do that. You can also be quite clever by going backwards. So I can have my start value as 11, my stop value as, well, we have to be careful here, because if my stop value is up to but not including, if I wanted to go to 0, I'd have to put -1 in. But let's just put 0, and this will give me 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. If I just clear the log and press play to make that a 10. So my start value is fine. I can start with 10, go down to 1. And if I wanted it to include the 0, I can do a -1, and that will give me 10, 9, 8, 6, 7, 6, 5, 4, 3, 2, 1, 0. There you go. So you can use start, stop, and step in the built-in range function to control my count values. So that's just giving you a sort of whistle-stop tour of the for loop functionality. So let's have another kind of example here. Let's have start number. I'm using camel case for here. Start number is an integer. Maybe we want it from the user. And we say enter a starting value and end number. I'm just going to copy this because it's just easier sometimes. Enter an ending value, or end might be better, an end value. So we're going to ask the user for two numbers. We're going to make them sure they're integers. And then what we can do is we can say we'll use count, but you could easily change that to anything else. I should note that the for loop will just go round and round multiple times, and count will take on the value of one of the numbers we put in there. So just going back to sort of line 3, the start value is 10, so count will be 10. Then the loop goes around again, and because we're counting backwards, because we do put a -1 in, count will then be equal to 9. Then count will be equal to 8. So count is a temporary variable that changes every single time the loop goes round. So here, for count in range, and what we could do is put our start number in, which we've got from the user at this point. And then we've got to be clever because we've got an end number, but because we go up to but not including it, we need to add 1 to it. So this will go from the starting value to the ending value that the user has done. And let's make this more interesting. Let's say, I'll just comment this one out for a second, because this is a different example. Let's say we want this only print out multiples, only print out numbers divisible by 5 or, I don't know, 3, right? So we've got something a little bit strange there, but that's fine. So we've got a loop that we're going to go from a starting value to an ending value, and we've got this condition that we want to have. So when we have conditions, we have our selection. If something is something, do something. So in this case, if count, what we want to be checking here is if something can be divided by 5, if it's evenly divisible by 5, or it's even divisible by 3, the remainders should be 0. So the logic here would be, if whatever our number is, modulus, the modulo operator, 5 does equal 0, or count modulo, let's say, so we just change this, or both, okay, or count modulo 3 does equal 0. So if it can be, if there are no remainders after dividing by 5, or no remainders after 3, we can then colon print count So let's try enter a starting value, I don't know, 200. Okay, so 3, 5, 6, 9. Okay, so all those numbers can be divisible by either 5 or 3. And we could easily change this to, as well, for both, we could have and. So we can check only numbers that can be divided by 5 and 3. Let me clear the console so it's a bit easier to see. Enter a starting value 1 to 100. Alright, there we go. So 15, 30, 45, 60, 75. That narrows it down quite a lot, doesn't it? So this or both things is where we could have and being used. So this reminds me of a famous counting game called FizzBuzz, which is a sort of low-level interview question that can be used as an interview question. And the rules are, if a number can be divided by 3 evenly, you say fizz. Divided by 5, say buzz. Or by both 3 and 5, say fizz buzz. So you would expect it to be 1, 2, fizz, because 3 can be divided by 3, and then 4, buzz, fizz, 7, 8, 9 can be divided by 3, so fizz, and then and buzz, and all the way up to 15, which is the first one we just found out is fizz buzz. All right. So I'm just abbreviating it here. That's what we expect it to say. So how could we tell the computer to count in that particular way? So what we could say is for I in range, for I, I'm just calling it I, let's just call it number, for in range, let's go from 1 to 101. So we do all the numbers from 1 to 100. If our number, and I'll put this in brackets, modulo, we want to check for the FizzBuzz condition first. If it can be divided by 5 with no remainders, and number modulo 3 has no remainders from it, then, I know I've missed a colon at the end, print fizz buzz. So that's our first condition we want to check for. Is it a fizz buzz condition? And then you can put elif number modulo 5 equals 0. We just say buzz. And then we've got another condition here. elif number modulo 3 does equal 0. Print fizz. Else, if it's none of those, just print the number. Just print the number, the variable. Okay. So I'm just going to comment these out just so that we're just running this one. Hopefully this will work. Okay, number. Okay, that's my spelling. rushing. Let's check. Does it work? 1, 2, fizz, 4 bars, fizz, 7, 8, fizz, bars, 11, and 15 is fizz bars. Great, it works. So it goes all the way up to 100 and checks whether they're fizz bars or fizz bars. So that's a nice way of showing iteration and selection and matching conditions. Let's do another fun example of like a times table generator. And we're going to, in order for doing this, we're going to use a nested for loop. So we're going to have a loop within a loop. So I'm going to say times table for I'm going to call it table, this temporary variable name, in range of my start value can be, I don't know, 2. I'm gonna display all the tables between 2 and 10. All right, so I need to put 11 in there. So I'll put a comment in there so you can see what's going on. Okay. And 10. All right, so I've got my numbers 2 to 10. So table is going to start off being the value 2. And while it's the value 2, I want to do more things to it. So then I can say for n in range, so n will just be a number that will be assigned to it, 1 to 11. So I can say 2 times 1 all the way up to 2 times 10. And I'm putting 11 in there because the stop value is up to but not including. Then I can have answer equals table, which is a number. In this case, the first time the loop goes around will be 2 times by n. And the outer loop table will stay as 2 for the whole time the inner loop n goes from 1 to 10. So then that way I can print out all of my multiplications. So I'm just going to put table, which is going to start off as 2, string, so put an x in there because people know that x is times, comma, n, comma, equals, comma, and then answer because I have a variable called answer. So let me just comment my fizz bars out of the way so it's not confusing you. Here we go. There. So we've got 2 times 1, 2 times 2, all the way up to 2 times 10, and then the inner loop has done its thing. Then it goes, table becomes 3, and n is 1, 2, 3, all the way up to 10, and then the outer loop table becomes 4, and it goes all the way up to 10. 10 times 10 is 100. So very quickly you can create something quite sophisticated using nested for loops. Now it's not very efficient to use nested for loops. It does take quite a lot of processing power, especially if the numbers are big. But you can see the power of nested for loops there. And we use them a lot in algorithms, like you'll see it in bubble sort, for example. So I think that's a good introduction to the idea of for loops and the parameters of them. I'm just going to show you one extra little bonus because there are 2 types of for loops, essentially. We've been using count controlled iteration, but there are for each loops as well, which are slightly different. And for this, I'm going to initialize a variable called a list, and this is a data structure that we haven't used yet. But a list is where we've got square brackets, and I could have, I don't know, A, B. I've got a whole load of strings. I got all the. Let's just say it's the alphabet in there. And a list is essentially just exactly what that name is. In this case, we're called an array because they're all the same data type. But in Python, it's the closest to an array is a list. Square brackets are all strings. And what I could do is if I wanted to iterate over each item in that list, I can use a for each loop. So I can say for letter, because it's a temporary variable name anyway, in a list, print letter. And that will give me A, B, C, and D, hopefully. There you go, A, B, C, and D. And it will look at each item in that list separately, go through them all, and then be printing them out, and it will stop. So that's not using count control, but it's what we call a for each loop, and it is also something that you have to know and use. Good.